Hi guys, Dr. G is again giving you a hard time. Now we're going to work with ray tracing and parabolic mirrors. And let's assume that this purple line here that you see here, a little bit curved, let's assume that that is actually a parabolic mirror. Okay. And here, well, first, before start solving a problem and solving this case in particular, let's look at some stuff that we all need to know. These axes here, this fellow here, is known as the axis, optical axis. Basically, it's optical axis. This is important. This thing here is the optical axis. This is the parabolic mirror. This is the focus of the mirror, and this is the center curvature, which is usually 2 times the focus, right? Okay, with all that in mind, if we draw here the first object. Here, let's draw here an object which is an arrow and is blue, and I hope you can see it because I put here the background black because the yellow thing looks much nicer. But here, things we need to learn how to do ray tracing with parabolic mirrors. One of the things, the way it goes is like this: a ray that it goes parallel to the optical axis. If you see my mouse moving there, when it hit the mirror, all those rays will converge in the focus. That's one of the rules. The other rule is a ray that it goes from the object to the focus, when it hit the mirror, it will go back parallel to the optical axis. So usually when you're doing ray tracing, you're going to trace those two rays first. And if they happen to converge at one point, well, those two rays converge is where the image is going to form. And if you remember, one of the discussion we were doing on Wednesday is if it converges at that point, the image is formed. If the image is formed the same side that is the object in parabolic mirror like this one, the concave one, the image is real. If it is going down from the optical axis, as well is downward, and the other thing characteristic you're going to check is the size. So 3 characteristics you're going to check on the image that is formed once you do the ray tracing is if it's upward or downward, if it's real or virtual, the image, and if it's bigger or smaller than the object. So let's do some ray tracing here for this example, which I put here, case A, an object beyond the center of curvature. The center of curvature is this way. We put the object far away. So let's do the ray tracing in a second. Let me fix this thing here. And look here. Wait, let me stop. Look here. A ray that it goes parallel to the optical axis, when it hit the mirror, it will converge and go through the focus. So let's see how it goes now. Okay, everybody see this? A ray that it goes parallel to the optical axis, when it hit the mirror, it will converge, it will go through the focus, and it will keep going all the way to all the way to infinite, right? Yeah, I mean, I'm doing cheating. I'm stopping here the video. I'm tracing this ray. We're using a program here, but that's okay. It's okay. What you want to see is this: that a ray that it goes parallel to the optical axis, when it hit the mirror, it will go converge to the focus. Now, let's do the next one. The one that goes from the object goes to the focus. What happened when it bounced back from the mirror? What happened? That's what we're going to see now in a second. Let me trace that one again. Now listen, guys. A ray that it goes from the object and it hit the focus. And, okay, it's slightly off from the focus because I assume the focus being here is slightly off, but I couldn't make it that it hit there. But it's okay. I assume that it's hitting the focus. When it hit the mirror here, it will go parallel to the optical axis. So you can see the ray that it goes through the focus. When it's hit the mirror, it will go parallel to the optical axis. And the point here, everybody see this point when these two rays intersect? Let me change this one because you see this point where these two rays intersect? The one that it goes first parallel to the optical axis, hit the mirror and go through the focus, and it keep going all the way down here in this direction. And then this one that it goes through the focus, hit the mirror, and it goes parallel to the optical axis. Here those two rays intersect. Here where those two rays intersect is where the image is formed. Yeah. Now in this case, the image what characteristics you see here? Well, first is real. It's a real image, right? Because it's formed at the same side that the object. Second, it's downward, right? Because it's going upside down. And third, okay, here it doesn't see because we are a little bit off the focus. It's actually, this one's supposed to be smaller. It doesn't see that it's small. Actually, it seems slightly bigger, but it's because we're off the focus. If we have come through the focus here, this ray will be going all the way this way, this direction, and it will show you that the image was going to be slightly smaller. But usually, for this case, for parabolic mirrors, for parabolic mirror in which the object is beyond the center of curvature, the image is going to be real. Put it here. Image is going to be real. It's going to be downward, and usually it's going to be smaller. Unfortunately for us, it doesn't see smaller, but it is. Okay. Okay, sorry guys, I had to change the characteristic here down and put it, well, characteristic, which is the things you have to tell me about the image, is real, is downward, and is smaller. Now, there's other things that we have to look here. Like if I ask you to calculate the focal length, or the distance where the object is going to be, or the distance where the image is going to be, then you need to know a couple of things. For example, the distance between the object and the mirror, and we're going to assume it's like, assuming that the mirror is like a vertical line here, that's what I put it here, it's called S, right? S is distance, object, mirror. I forgot the I here, somewhere else. Object, mirror, you know what it is. Okay, S prime is this distance. S prime is the distance between image, mirror. So this is S prime, distance between image and mirror. And the focus, well here it is. We know this is going to be F. This is distance. Well, the focus, the way we, it's going to be there determinate. And the way you calculate the focal length for this thing, I'm going to write the equation here. It's going to be 1 over F is equal to 1 over S plus 1 over S prime. And I think I mentioned this thing in the last class, in last video. Anyway, this is how we calculate the focal length. And actually, this is the equation to calculate the focal length. The way you calculate the focal length, I'm going to move this a little bit down, is not using this exactly here, because this will look like calculating the total resistance of a circuit with resistors in parallel or capacitors in series. The way you do is F is going to be equal to S prime divided by S plus S prime. Yeah, it's like finding the reciprocal of this thing, which if you find the reciprocal of this fellow, the easiest way would be F is going to be equal to 1 over S plus 1 over S prime. Yeah. And sometimes I'm going to ask you to find, what is the object, which is this, or sometimes I will ask you to find where is the image, which is S prime, or sometimes I'm going to ask you to calculate the focal length, right? Okay, but in that case I have to give you the other distance. The distance of the object to the mirror and the image to the mirror. And we have these two, S and S prime, distance from object to, from mirror, distance image from mirror. And okay, and let's do another case. Now guys, let's do the same thing. Ray tracing for an object that is actually at the center of curvature. I did a little bit smaller here to see where this time I don't miss badly. So let's try the first ray. A ray that goes parallel to the optical axis. When it hit the mirror, it will go through the focus. So let's see that one. So here we have it. A ray that goes parallel to the optical axis. When it hit the mirror, it will go through the focus. Okay, this time I didn't miss. Great. Right? That's the first ray we always trace. One that it goes parallel to the optical axis. When it hit the mirror, it will go through the focus. Now we need one that it goes through the focus and see what's happened. What it intersects. Then we have the ray that when it goes through the focus, go through the focus. When it hit the mirror, it will go parallel to the optical axis. And here where these two intersect, this point here, well, it should be something like this, is where the image is formed. And the image characteristic we see here, well, first is downward. Well, it's real. This first is real. It's a real image. Second thing is downward. Okay, downward. Whatever is that, it's supposed to be downward. And third, here's the thing that I missed. It should be exactly here. It should be same size. Yeah, but you know, I miss it because okay, look, I tried my best with this ray tracing, and this is not a nice mirror. So, but that's actually what happened. So, a ray that goes through the focus, when I hit the mirror, it will converge. It will go parallel to the optical axis, and where these two rays converge, which was this point here, that's where the image is formed. The image formed a little bit from the which should be. It should be exactly the same position, center curvature. But okay, yeah, just bear with me with this thing, okay? I will do another one.